The Bermuda Triangle is not marked on any official map. There are no warning signs, no visible boundaries, no line drawn across the ocean to tell you where it begins. And yet, for decades, this region has carried a reputation unlike any other place on Earth. Stretching roughly between Miami, Bermuda, and Puerto Rico, this vast triangle of ocean covers over 500,000 square miles of open water. It sits along one of the busiest maritime and aviation corridors in the world, a critical route for cargo ships, passenger flights, and military operations. On the surface, it appears ordinary. The waters are warm. The skies are often clear. Shipping lanes are active. Aircraft pass overhead every day. But beneath that normalcy lies a long history of disappearances that have shaped one of the most enduring mysteries of the modern age. Old ships have vanished without sending distress signals. Aircraft have disappeared mid-flight, leaving no trace on radar. Entire crews, experienced, trained, and prepared, have been lost without explanation. In many cases, there were no storms, no warning signs, no final messages. Just silence. The term Bermuda Triangle itself did not emerge until the mid-20th century, when writers and investigators began connecting a series of unexplained incidents in this region. What followed was a wave of attention. Books, reports, and global fascination, turning this stretch of ocean into a symbol of danger and mystery. But behind the legend lies something more complex. Not every disappearance is unexplainable. Not every incident is mysterious. And not every story is what it first appears to be. Some are the result of powerful natural forces, currents, storms, and sudden environmental shifts. Others point to human error, mechanical failure, or miscalculation in one of the most unforgiving environments on Earth. Because the ocean does not need myths to be dangerous. It is already unpredictable, already immense, already capable of overwhelming even the most advanced technology. The Bermuda Triangle is not a supernatural place, but it is a place where conditions can change without warning, where navigation can become uncertain, where small mistakes can quickly become irreversible. And in a region this vast, even a single failure can mean disappearing without a trace. The question is not whether the Bermuda Triangle is real. The question is why so many have been lost here, and what the ocean reveals when things go wrong. Section 2. Geography and Physical Conditions. At first glance, the Bermuda Triangle does not appear dangerous. There are no jagged cliffs rising from the sea, no visible hazards breaking the surface, no immediate signs of threat. But beneath the calm exterior lies a complex and unforgiving environment, one shaped by depth, movement, and instability. The region sits at the edge of the Atlantic Ocean's western basin, where the seafloor drops dramatically into deep trenches and abyssal plains. In some areas, the ocean plunges to depths of over 27,000 feet. These sudden changes in elevation create underwater landscapes that are anything but uniform. If something sinks here, it doesn't settle in shallow waters. It disappears into darkness, or far below the reach of sunlight, into terrain that is difficult, and often impossible, to search. This alone makes recovery operations incredibly challenging. Wreckage, if it exists, can scatter across vast distances or sink beyond detection. But the depth is only part of the danger. Running directly through the Bermuda Triangle is one of the most powerful ocean currents on Earth, the Gulf Stream. This current moves like a river within the ocean, warm, fast, and relentless. It can reach speeds of up to 4 knots, strong enough to carry debris far from its original location in a matter of hours. For investigators, this creates a critical problem. Even if a ship sinks, or an aircraft crashes, any floating evidence can be swept away almost immediately. Search areas expand, timelines shrink, and the chances of finding anything drop rapidly. The Gulf Stream does not just move water, it erases traces, Adding to this complexity are the region's numerous underwater ridges, seamounts, and plateaus. Some rise sharply from the ocean floor, while others form uneven terrain that can disrupt currents and create localized turbulence beneath the surface. To a vessel above, the water may seem calm. But below, forces are constantly shifting. Then there is the matter of traffic. The Bermuda Triangle lies along one of the busiest shipping routes in the Atlantic. Cargo vessels, oil tankers, fishing boats, private yachts, all pass through this region daily. Above them, commercial aircraft follow tightly scheduled flight paths connecting North America, the Caribbean, and Europe. This constant movement increases risk. More vessels, more flights, more opportunities for something to go wrong. And when it does, the scale of the ocean works against any chance of quick recovery. Distances here are vast. A distress signal may travel only so far. Rescue teams may take hours to arrive, and in that time, conditions can change completely. A calm sea can become unstable. Visibility can drop. Position data can become uncertain. In an environment this large, even modern navigation systems are not immune to error. Small deviations can grow into critical miscalculations, especially when combined with shifting currents and limited reference points. Because out here, there are no landmarks, no fixed points, no sense of scale, just open water in every direction. The Bermuda Triangle is not defined by a single hazard, it is defined by the interaction of many. Depth that conceals, currents that carry, terrain that complicates, and distance that isolates. Individually, these factors are manageable, but together, they create a system where mistakes are harder to detect, harder to correct, and far more likely to end without answers. Section 3. Environmental Systems. The Bermuda Triangle is shaped not just by where it is, but by how it behaves. This is a region where multiple environmental systems overlap, each one capable of turning a routine journey into a crisis. And often, they do it without warning. One of the most immediate threats comes from the weather. The Atlantic in this region is highly unstable. Warm tropical air collides with cooler systems from the north, creating conditions where storms can form rapidly, sometimes in less than an hour. Now, clear skies can shift to violent turbulence. Calm seas can rise into chaotic waves. Visibility can vanish almost instantly. These are not always large, predictable storms tracked by satellites. Some are localized, short-lived, but intense enough to overwhelm smaller vessels or disorient aircraft. Then there are waterspouts, rotating columns of air and mist that form over the ocean's surface. From a distance, they appear almost harmless, but up close they can produce powerful winds capable of damaging boats or disrupting low-flying aircraft. And beyond the storms, there is the sea itself. The Bermuda Triangle lies in a zone where rogue waves are more likely to occur. These are massive, unexpected walls of water that rise without pattern or warning. No buildup, no sequence, just a sudden surge. Waves that can exceed 30 meters in height. For a ship caught in their path, there is little time to react. Even large vessels can be severely damaged or capsized within seconds. For smaller boats, survival becomes nearly impossible, but not all dangers are visible. Some exist beneath the surface. One of the most debated theories involves methane gas hydrates, deposits of gas trapped within the ocean floor. Under certain conditions, these can be released suddenly, forming large bubbles that rise rapidly through the water. If a vessel is above such a release, the density of the water decreases. The result is immediate: loss of buoyancy, loss of stability, and potentially rapid sinking. In this scenario, a ship does not struggle or send distress signals. It simply drops, and the ocean closes over it. For aircraft, the danger is different, but just as real. Methane rising into the atmosphere can disrupt engine performance, reducing lift and causing mechanical failure. Combined with poor visibility and turbulent air, pilots may have only seconds to respond. Then there is the issue of magnetism. The Bermuda Triangle is one of the few places on Earth where true north and magnetic north align more closely than usual. While this may sound insignificant, it has historically caused confusion for navigators relying on compasses. In earlier decades, especially before advanced GPS systems, this variation could lead to subtle but critical errors in direction. A slight misreading, a gradual drift off course, and eventually, complete disorientation. Even today, electronic systems are not immune. Instrument failure, signal interference, or human misinterpretation can still occur, especially under pressure. And in an environment with no visual reference points, being off course by even a small margin can lead to serious consequences, because once you lose your position here, there is nothing to guide you back. These systems, weather, waves, gas releases, magnetic variation, do not operate in isolation. They overlap, interact, and amplify one another. A storm may form while currents shift. A compass error may occur during low visibility. A rogue wave may strike when communication is already compromised. Each factor alone is survivable. But together, they create moments where control is lost faster than it can be regained. And in those moments, decisions become irreversible. Section 4. Historical discovery/early exploration. Long before the Bermuda Triangle had a name, it was already a place of uncertainty. The first recorded encounter dates back to 1492. Christopher Columbus, crossing the Atlantic on his first voyage, entered these waters without knowing what lay ahead. His logs describe something unusual, a compass that no longer pointed consistently north. At the time, navigation depended entirely on such instruments. A drifting compass meant one thing: uncertainty. Columbus also reported strange lights on the horizon, distant, flickering, unexplained. His crew grew uneasy. The ocean was vast, unfamiliar, and now unpredictable. They continued forward. But something had changed. The sea was no longer just a passage. It had become a place of doubt. As centuries passed, thus this region grew in importance. Trade routes expanded across the Atlantic, linking Europe, the Caribbean, and the Americas. Ships carrying cargo, resources, and people moved through these waters in increasing numbers. With that movement came risk. Early sailors faced an environment they did not fully understand. There were no accurate maps of underwater terrain, no reliable forecasts, no real knowledge of ocean currents or atmospheric behavior. Storms appeared without warning. Navigation relied on instinct and limited tools, and mistakes were often fatal. Many ships were lost, some wrecked in storms, others disappeared entirely. Records from the 18th and 19th centuries describe vessels found abandoned, sails intact, cargo untouched, but no crew on board. In other cases, ships simply failed to arrive at their destination, leaving behind no explanation. At the time, these incidents were not connected. They were seen as isolated tragedies, part of the inherent danger of sea travel. But the pattern was forming. As navigation technology improved in the late 19th and early 20th centuries, expectations changed. Ships became larger, routes more precise, communication more reliable. The ocean, it seemed, was becoming more predictable. But in this region, that assumption did not always hold. Even as tools advanced, reports of unusual behavior continued. Compass variations, sudden storms, equipment malfunctions, experienced crews encountering conditions they could not explain. Then came aviation. Aircraft introduced a new dimension to the region: faster travel, higher altitude, and reliance on increasingly complex instruments. Flights began crossing the same waters that had challenged sailors for centuries. And soon, they too would encounter problems. By the mid-20th century, a series of high-profile disappearances began to draw attention. These were not small vessels or inexperienced crews. They were military aircraft, commercial planes, Large, well-equipped ships, and they were vanishing. Not always in storms, not always under extreme conditions. Sometimes in calm weather, with no clear cause. It was during this period that the idea of the Bermuda Triangle began to take shape. Writers and investigators started connecting these incidents, mapping them within a loosely defined triangular region. What had once been scattered reports became something more focused. A pattern, a question. Why here? Why do so many incidents occur in this specific area? And why do so many of them leave so little behind? The early history of the Bermuda Triangle is not defined by a single event. It is defined by accumulation, small anomalies, unanswered questions, and a growing sense that this region behaves differently, not in ways that defy nature, but in ways that reveal how little was truly understood. Because even as technology improved, the ocean remained the same, unpredictable, unforgiving, and capable of turning even the most prepared journey into a disappearance. Section 5. Real Incidents and Disasters. The reputation of the Bermuda Triangle is not built on theory. It is built on real events, documented, investigated, and in many cases, never fully explained. These are not isolated stories, i.e., they are moments where something went wrong, often quickly, often without warning, in a region where recovery is never guaranteed. USS Cyclops, 1918. In March 1918, the USS Cyclops departed from Barbados bound for Baltimore. It was one of the largest ships in the U.S. Navy at the time, a massive cargo vessel carrying over 10,000 tons of manganese ore. On board were 309 crew and passengers. The weather was calm. The route was familiar. There were no reported issues. And then, nothing. No distress signal, no debris, no final transmission. The Cyclops simply vanished somewhere within the triangle. Search efforts found no trace, no wreckage, no explanation. To this day, it remains the single largest loss of life in U.S. naval history not involving combat. A ship that large, gone without a trace. Flight 19, 1945. December 5, 1945. 5 U.S. Navy training aircraft, known collectively as Flight 19, took off from Fort Lauderdale for a routine navigation exercise. The pilots were experienced. The weather was initially clear, but during the flight, something began to go wrong. Radio transmissions captured confusion. Compasses were malfunctioning. The lead pilot reported he could not determine his position. The ocean below looked unfamiliar. As the situation worsened, communication became increasingly disoriented. We don't know where we are. Everything looks wrong, even the ocean. Fuel levels dropped. Instructions from base were given, but not clearly followed. And then, silence. All 5 aircraft disappeared. A rescue plane sent to locate them, a PBM Mariner with 13 crew on board, also vanished shortly after takeoff. No wreckage from either group was ever confirmed. 37 men, lost within hours. A routine training mission that never returned. Douglas DC-3, Flight NC 16002, 1948. On December 28, 1948, a Douglas DC-3 passenger aircraft departed from San Juan, Puerto Rico, heading toward Miami. On board were 32 people. The flight was expected to be routine. Weather conditions were not extreme. Communication with air traffic control was maintained. But as the aircraft approached Florida, the signals began to fade. The final transmission indicated the plane was approximately 50 miles from Miami. Then contact was lost. No distress call was sent. No emergency declared. Search operations covered thousands of square miles. Nothing was found. No debris. No bodies. No confirmed crash site. Yet an aircraft within sight of its destination. That never arrived. Star Tiger and Star Ariel, 1948 to 1949. Within just 1 year, 2 British passenger aircraft disappeared over the same region. In January 1948, the Star Tiger vanished while flying from the Azores to Bermuda. Conditions were challenging but not catastrophic. Communication was normal. Until it wasn't. The aircraft never reached Bermuda. No wreckage was ever recovered. Then, in January 1949, the Star Ariel disappeared on a similar route. This time, conditions were even better. Clear skies, stable flight. The last transmission reported no issues. And then, silence. 2 aircraft, 2 separate incidents, both gone without a trace. Despite extensive investigation, no definitive cause was ever established. SS Marine Sulphur Queen, 1963. In February 1963, the Marine Sulphur Queen left Beaumont, Texas, carrying molten sulfur. The ship had undergone structural modifications to carry this hazardous cargo, changes that some experts later questioned. As it entered the waters near Florida, contact was lost. No distress signal, no warning. Search teams eventually found small pieces of debris, life jackets, fragments of the vessel, scattered across the ocean, but the main wreckage was never located. All 39 crew members were lost. Investigators suggested structural failure as a possible cause, but without the ship itself, certainty was impossible. A vessel carrying dangerous cargo, lost in open water, with only fragments left behind. Witchcraft Cabin Cruiser, 1967. December 1967. A small but well-equipped cabin cruiser named Witchcraft departed from Miami, was heading just a mile offshore. Its captain, an experienced operator, called the Coast Guard shortly after departure. He reported hitting something, but was not in immediate danger. Help was dispatched immediately. It should have been a simple recovery, but when rescuers arrived, the boat was gone. No wreckage, no survivors, no trace. The water was calm. Visibility was clear. A vessel so close to shore that vanished before help could arrive. El Faro Cargo Ship, 2015. Not all incidents belong to the past. In October 2015, the cargo ship El Faro sailed into the path of Hurricane Joaquin. Unlike earlier disappearances, this event was tracked in real time. The crew knew the storm was approaching. Weather data was available. Communication systems were active. But the storm intensified rapidly. Conditions became extreme. The ship lost propulsion. Flooding began. Power systems failed. Final transmissions captured the crew's struggle. Then, silence. The ship sank with all 33 crew members on board. Unlike earlier cases, the wreckage was eventually found, over 15,000 feet below the surface. The investigation revealed a combination of human decisions and environmental forces. A modern ship, advanced technology, and still, the ocean prevailed. These incidents are not identical. Some occurred in storms, others in calm conditions. Some left debris, others left nothing at all. But they share one critical reality. In this region, when something goes wrong, it can go wrong completely. No time to react, no chance to recover, and often, no answers left behind. The Bermuda Triangle is not defined by mystery alone. It is defined by moments where control is lost, and the ocean takes everything that follows. Section 6. Modern Encounters/Present-Day Risks. Today, the Bermuda Triangle is no longer a blank space on the map. It is heavily traveled, closely monitored, and supported by some of the most advanced navigation systems ever developed. Aircraft rely on GPS, satellite tracking, and real-time communication. Ships use radar, sonar, automated routing, and weather forecasting systems. On paper, the risks should be lower than ever, and in many ways they are. But the ocean has not changed, and neither have the conditions that make this region unpredictable. Modern incidents in the Bermuda Triangle rarely involve complete disappearances without explanation. Technology has reduced uncertainty, but it has not eliminated danger. Pilots still report sudden turbulence, clear skies turning unstable within minutes, instrument readings shifting unexpectedly, moments where visual references disappear into haze or glare. In aviation, even brief disorientation can become critical. At high speeds and altitude, there is little margin for error. A misreading, a delayed reaction, and recovery becomes difficult. For ships, the risks are different, but just as real. The Gulf Stream continues to move with immense force, capable of pushing vessels off course or accelerating the spread of debris during an emergency. Weather systems still form rapidly. Hurricanes remain the most visible threat, but smaller, fast-forming storms can be just as dangerous, especially for smaller vessels or those caught unprepared. Even experienced captains must constantly adjust. Route changes, speed reductions, continuous monitoring, because once conditions begin to shift, options narrow quickly. There is also the issue of overconfidence. Modern technology creates a sense of control, precise navigation, accurate forecasting, constant communication. But these systems depend on interpretation. Data must be understood, decisions must be made, and under pressure, human judgment can still fail. The loss of the El Faro demonstrated this clearly. Despite access to detailed weather data, the ship's course placed it directly in the path of a strengthening hurricane. Decisions made hours earlier could not be reversed once conditions escalated. Technology did not fail. The situation did. Because even with modern tools, timing matters, and the ocean does not wait. There are also limitations that remain. And satellite coverage can be disrupted. Communication signals can weaken or drop. Equipment can malfunction. These are rare events, but when they occur in a region this vast, the consequences are amplified. Search and rescue operations, while more advanced, still face the same fundamental challenge: distance. If an aircraft goes down, response time is critical. If a ship sends a distress signal, its last known position may already be outdated by the time help arrives. Currents shift, weather changes, visibility drops, and the search area expands rapidly. Even today, finding wreckage in deep ocean environments remains extremely difficult. Black boxes can be lost. Debris can sink beyond reach. Evidence can be scattered across miles of open water. The difference now is that more is understood. Investigations are more detailed. And data is more complete. Explanations are more grounded. But not every case is resolved with certainty, and not every incident leaves enough information behind. The Bermuda Triangle no longer relies on mystery to be dangerous. It is dangerous because it is active. A region where weather, currents, and human decisions intersect constantly, where conditions can change faster than systems can respond, and where even today, a single mistake, a single delay, or a single miscalculation can still lead to a situation that cannot be reversed. Section 7. Scientific explanations versus mystery. For decades, the Bermuda Triangle has been surrounded by speculation, stories of vanishing ships, lost aircraft, unexplained phenomena. And with those stories came theories. Some suggested unknown forces, and others pointed to extraterrestrial involvement. Even ideas of time distortion and hidden dimensions emerged. But when examined closely, most of these explanations do not hold. What remains is something far more grounded and far more unsettling. Because the real explanation is not a single cause, it is a combination of factors, all operating within one of the most complex environments on Earth. Weather is the first. Sudden storms, microbursts, and hurricanes account for many incidents. These are measurable, observable, and well documented. But their unpredictability remains a challenge, especially in earlier decades when forecasting was limited. Then there are ocean currents. The Gulf Stream does not just move water, it removes evidence. Debris is carried away quickly, making it appear as if nothing ever happened. In reality, the signs are simply no longer where they should be. Human error is another major factor. Navigation mistakes, miscommunication, poor decision-making under pressure. Even experienced crews are not immune. In high-stress situations, small errors can escalate rapidly, especially in an environment with few reference points. Mechanical failure also plays a role. Engines fail, instruments malfunction, structures weaken under stress. In some cases, these failures are known. In others, they are only inferred, because the evidence is lost with the vessel itself. Then there are less visible phenomena. Methane gas eruptions from the seafloor have been studied as a possible cause of sudden sinkings. While not proven in every case, the science supports the possibility. A rapid release could destabilize water and affect buoyancy. Magnetic variation, once a significant issue, is now better understood, but historically it contributed to navigation confusion in the region. None of these explanations are extraordinary on their own. They exist in oceans all over the world. But here, they overlap. They occur in the same region, along the same routes, under conditions that can change without warning. This creates a pattern, not of mystery, but of vulnerability. And yet, the legend persists. Why? Because some cases remain incomplete. No wreckage found, no final signals recovered, no definitive answers. These gaps leave space for speculation. When something disappears completely, it invites interpretation. But absence of evidence is not evidence of the unknown. It is often the result of environment, depth that hides, currents that scatter, a distance that delays response. The Bermuda Triangle does not defy science. It reinforces it. It shows what happens when multiple natural forces converge, and when human systems are pushed beyond their limits. The mystery is not that things vanish here. The mystery is how easily they can be lost, and how difficult it is to recover what remains. Section 8. Final conclusion. The Bermuda Triangle is not a place of supernatural forces. It is something far more real, a region where the ocean reveals its true nature, unpredictable, unforgiving, and indifferent to those who cross it. For centuries, humans have moved through these waters with increasing confidence. Ships became stronger, aircraft became faster, navigation became precise. Technology gave the illusion of control, but the ocean was never controlled, only understood, to a point. Because in places like this, understanding has limits. The Bermuda Triangle is not defined by how many disappearances have occurred. It is defined by how those disappearances happen, quickly, quietly, and often without a chance to respond. A shift in weather, a failure in judgment, a moment of disorientation, and suddenly, everything changes. The stories of lost ships and missing aircraft are not just records of tragedy. They are reminders that even in the modern world, there are environments where control can be lost in seconds, where systems fail, where preparation is not always enough, and where recovery is never guaranteed, because once something is taken by the ocean here, it may never be seen again. The Bermuda Triangle does not need mystery to remain feared. Its danger is real. It exists in the depth of its waters, in the speed of its currents, in the instability of its skies, and in the vastness that surrounds it. A place where distance isolates, where evidence disappears, and where silence follows quickly after failure. In the end, the Bermuda Triangle is not a puzzle waiting to be solved. It is a boundary between what humans can manage and what nature will always control. And in that boundary, there are no guarantees, only the open ocean and the consequences of entering it.